live.
Hey, good morning, everyone. Hi. Good morning. Hi, Troy. How's it going? Hey. How's it going? Good morning, guys, and good afternoon, depending on when you woke up. Welcome to RITSEC. So we're going to get things kicked off pretty quick here. If you guys could go ahead and sign in at signin.ritsec.club. You guys are all really smart and going to remember that, so I'm not going to stay on the slide. We're actually going to get started with the announcements. And we have a special department announcement with Rob Olson. So could everyone give him a warm welcome?
You want me to use this mic? Yeah. Okay. Use both mics? Okay. Oh. What just happened? I think it registered. Oh, there we go. It's going to be over here. Cool. Okay. All right, everybody. So two announcements from the department. First, we're going to have some co-ops available through SafeLab. The exact number is still up in the air a little bit. We're going to have at least 1 to 2 summer positions doing Internet of Things penetration testing. Penetration testing is in air quotes because it does tend to shake out to be a little bit more like vulnerability assessment rather than straight pen tests. They're typically isolated IoT devices. Important skills. Most of the IoT devices we're looking at run Linux under the hood, certainly looking at network services, network security, looking at web applications. Pretty much all of the IoT devices we look at run a web stack, run a LAMP stack, and certainly documenting vulnerabilities. We may have two additional positions coming through. We are still waiting to hear back from the DoD as to whether or not we're going to get these particular co-ops. They are for web application assessments for the Department of Defense for various things. So it will largely be a web application penetration testing. These other two would largely be web application penetration testing options. So questions about these before I move on? Okay, if you are potentially interested in these, feel free to come talk to me. Secondly, CPTC team tryout. So we are trying to actually get CPTC going this semester rather than waiting until the fall. Something new and hopefully a little bit better will let us organize a little bit more effectively. We're going to have some tryouts. The tryouts are going to be like what we have done in the past where we have a penetration test. This time we're going to scale this up a little bit, and this is also going to be a forcing function for me because not that much different from ISTS and the state of our infrastructure right now. Okay? Yeah? No, actually, I think you guys might be in better shape.
Build it all in one night?
No, 1 month. 1 month. The testing for this will be 4/8 to 4/15. So that's the 8th of April to the 15th of April. That's Monday to Monday. We're going to want a full report of your penetration test by 4/16 and to present reports by 4/18 on 4/18 and 4/19. So when you get your reports in, if you are interested in trying out, we'll get your reports in and we will actually have you present your findings. The reason we do this is because CPTC, yes, it is a hacking competition sort of, but it's not really a hacking competition. Okay? They actually only count your technical findings for about 1/3 of your score. It's equal parts writing and presentation skills. Because really, this is about doing a penetration test, not doing a capture the flag. And what they're looking for is you as a penetration tester to generate business value as part of the competition. Okay, so it's very heavily focused on writing and presenting. Okay. Feel free to sign up at the CSEC office. I actually need to now tell Rita that you're all going to be signing up there by 4/1. And the reason we're doing that a little bit early is to make sure that we get any accounts that we need to create for you as a part of this penetration test, we can get those set up in advance of the 4/8 deadline. Okay? Questions about CPTC? Cool. I'm going to hand this back to Russ then.
Thank you very much.
Thank you.
That's what I like to see. All right. Okie doke. Well, thank you, Rob. I don't know if I think you kind of ran out, but thank you to him. And yeah, definitely consider CBTC. It's a great opportunity to learn both penetration testing skills and like also develop some more professional skills, which are honestly a lot more valuable sometimes because you're going to be using them all throughout your career. So, but anyways, oh, we have, sorry, Loudon, right? Yeah, so Loudon is going to come and talk about the physical security interest group. So give him a warm welcome.
Yes.
You go, buddy.
How do I use this?
Just talk into it.
Is this working? Can you guys hear me?
Don't, you have to.
Hello? Okay. I don't need that really, but so somehow I managed to get an interest group set up.
Hey,
and,
Loudon, if you want to be heard on the stream, you need the other mic.
Oh, that's what this is for. Figured I was talking loud enough. Probably was not. There. Now they can hear me. Anyway, so I founded an interest group about physical security. It's mainly focused around locks. The first meeting is going to be this Saturday at 1 in Air Gap, I believe. That may change. I did not get any like official say that I could use that room, but also apparently there's a workplace group. Scott did that. Major shout out, Scott. Major shout out. Yeah, so you should show up. The first meeting is going to be an introduction and just like basics and resources you could need and tools and stuff. That's what it's going to be about. You should come out. It's going to be cool. Question?
Do you have experience picking locks?
Yes.
Yo, 1v1 me.
1v1 me. Yes, I created this club with no experience. It's just a joke. No, I do. Pick the Medico, bro. Anyway, yeah, that's the pitch. Come on out. It's gonna be great. You don't need to bring anything.
I might drop, I guess.
I ruined the whole club meeting.
All right, well, if that wasn't a good enough pitch, I mean, I don't have to say anything else. I think the pitch just sold itself, so yeah, definitely show up to that. I don't think I need to say anything else. Thank you, Loudon, I appreciate that.
You're welcome.
So next up, we have a very special guest speaker coming all the way out from Seattle. Redmond, Seattle? Yes, Redmond, Seattle. Sarah Jacobus can come on down. Oh, wait, sorry. We're gonna meet the sponsors after, so come on down, Sarah. This is like, what's that? Sure, yeah, that was it.
Nope. Here's USB-C.
That's over here.
Yeah. Let's hope it works. Hell yeah.
So yeah, that's for the stream. This is for like just overall being louder. So.
It's being streamed. All right, cool. Thank you.
Yep. No.
All right, hello everybody. My name is Sarah Jacobus. I graduated in May of 2018, so not all that long ago. I work at Microsoft. I'm a security program manager, and I work on the Microsoft Security Response Center team. So essentially, I work for Microsoft's bug bounty program. I was on the RC3 e-board as competition architect for a hot second, and I threw in a couple of questions throughout my presentation today, and I brought with me some Microsoft Challenge coins. For those of you who don't know, Challenge coins are coins that are handed out. They initially started out that people in the Army and that worked in the service would get Challenge coins, and it was kind of a way to maybe show your status or show a challenge that you completed. So we have these Microsoft ones, so I'm not going to attempt to throw them, but if you get any questions right, I'll leave them out on the table and you can come grab one afterwards. Also another quick thing, so my goal here in this presentation, even though I work for Microsoft, I'm not looking to promote Microsoft specifically bug bounty program. I'm just trying to bring more awareness to bug bounty programs in general, not just Microsoft's. That being said, quick disclaimer that I had to put in here. The opinions in this presentation are mine, not Microsoft's. So yeah, our legal team makes us put in this for all of our presentations. All right, so first up, first question. Can anyone tell me what a bug bounty program is? Does anyone know? Yeah.
You submit vulnerabilities that you find to a company and then they hopefully pay you.
Yes. Absolutely, great answer. So it is technically defined a crowdsourcing initiative that rewards people for reporting vulnerabilities that are found in company software. So this is usually in the means of money, but it can also be an acknowledgement as well. And I'll go into that a little bit later. So as security researchers, as students that are passionate about security, it is very likely that at some point in your career, you will find or come across a vulnerability in company software. This could be through a pen test, this could be by accident, something that you just come across, or this could be something that you're actively looking to find. So with this vulnerability, there's a couple things that you can do. The first is you can exploit it. For the purpose of this presentation, I'm just assuming that we're all white hat hackers here, and this is not something that we're looking to do. The next thing that you can do is you can publicly disclose this vulnerability that you found on a blog, on Twitter, on whatever means that you are looking to publicly disclose it. This is something that I really want to discourage you against from doing for two main reasons. The first is if you ever plan to participate in a bug bounty program, it is likely that publicly disclosing or dropping a 0-day on a company will blackball you from participating in these bug bounty programs. The other one, and this is something that I hadn't really considered until I started speaking to my team about this, but when you're posting these vulnerabilities online, this isn't necessarily like just for your street cred or showing off that you found this vulnerability. There are bad guys out there that are actively looking to find these 0-days dropped and use them against companies and other governments. I know for us a big thing is that Microsoft has Windows, and our government primarily uses Windows. So if someone drops an 0-day on Windows, they might think that they're just like going after Microsoft or going after Microsoft users, but this is actually a huge issue for the American government. Lastly, and this is what I'm here to talk to you guys about today, you can submit this vulnerability to a bug bounty program. So why participate? The first and maybe the most obvious is cash money. A lot of organizations will pay up to $200,000 or $250,000 for these vulnerabilities that you found. This isn't super common getting this big of a payout. I work for the online program. We probably see more like from the $1,000 to $5,000 range per bug reported. But we do actually have one of our main finders is a college student from the UK. He gets from us maybe about $100,000 a year just by participating from this program. So it is easy to get pretty big payouts very quickly. So the other main reason that you want to participate in these programs is getting acknowledgement. And the biggest acknowledgement that most people are after is a CVE. This is my second question. Does anyone know what a CVE is? In the back. Yes.
Oh, I have to answer? Oh.
Yeah.
It's a common vulnerability something or other, and the CVE program is run by MITRE, and you submit a bug, they say, good job, we verified it, here's your CVE number, and then you have to memorize it and put it on your resume. And then when people ask you what something cool you did, you'd be like, oh, well, I found CVE 2018 something, something, something.
Yes, exactly. So they are distributed by MITRE, and it's essentially a number that you are given for getting a vulnerability that you found fixed. So an important note or distinction to make about these CVEs is that they are only applicable for inbox products. They do not apply to pretty much any online products out there. So a CVE looks amazing on your resume. If you're looking for something to beef up your resume, this is a really great thing to have on there. That being said, if you want to go after online acknowledgements, most companies, I know, for example, Microsoft has an online researcher acknowledgement page where you don't necessarily get a CVE number, but they will still give you a shout out. They acknowledge you by name, maybe your Twitter, whatever information that you want on there. And adding a link to that on your resume also looks great. Another couple reasons, personal development, it's a great way to learn. It's part-time. You can do it as a student. You can do it as a full-time job, or you can do it in conjunction with your full-time job. And if you're looking for something to talk about at a conference or giving a tech talk, talking about a vulnerability that you found is a really great way to go about doing this. Another quick note, if you are looking to give a talk, many conferences, though not all, will prohibit you from dropping an O-Day on a company as a tech talk. So it is likely that you want to participate in a bug bounty program, submit this vulnerability, wait until it gets fixed, and then give that talk at a conference. So there's two different types of bug bounty programs. The first is a company-run bug bounty program. So that's going to be your Apple, Facebook, Google, Microsoft. There are many, many, many more that are not even on here. But this is, for example, a lot of these big companies have the infrastructure and they have the numbers of people that can triage the reports, reproduce it, get it fixed, get these CVE articles out. So this is one way to report the bug directly to an organization that has one of these programs set up. But the other big way is going through a third-party program. You may have heard of some of these before, but the two really big ones is BugCrowd and HackerOne. Essentially, say you have a company, Twitter, who doesn't have the infrastructure set up. They don't want to go through the process of hiring all the people, having the people that can set up a bug bounty program. They'll have HackerOne or BugCrowd set up this program for them. So this is another option. You can go through one of these organizations to report your vulnerability. There's two other that I want to talk about. There's Zero Day Initiative. They're a little unique. They sell a software called Trend Micro, and their business model is if you want to report a vulnerability for Apple, you tell Zero Day Initiative about it first, and ZDI will pay you. For that, they will fix that vulnerability in their software for their customers, and then they'll go to Apple and say, hey, someone reported this vulnerability to us, and we're giving you guys 90 days to fix this. Because they're imposing that timeline on a bug bounty program, they are not eligible for bounty. And this is a really big distinction to make. When you're submitting a vulnerability, they will say, you know, we guarantee that we will fix this bug in 120 or whatever their deadline is. But if you tell them, you know, I'm giving a talk in 3 days, you have X amount of time to fix this, you are making yourself ineligible for bounty by imposing that timeline on them. So another big company, program that has this is Google Project Zero. This is almost like a non-for-profit organization. Google has a team of people whose main job is just to go out, find vulnerabilities, and get them fixed. They also impose this timeline, but they're not looking to get paid. Their goal is just to go out and get these bugs fixed. All right, so know your rights and know some of the terms before you go ahead and start submitting vulnerabilities. The first I just touched on is SLA, or Service License Agreement. This is the amount of time that a company has agreed to respond to you, to get back to you. This is really important to know. Some companies say, you know, we guarantee that we will respond to your email in 24 hours, or that we will reproduce your report in 10 days. This is really important to know when you're submitting a vulnerability. You want to know what the company has publicly said or agreed to. The next is CVD. This is my other question. Does anyone know what CVD is, or Coordinated Vulnerability Disclosure? This is actually one of my favorite reports that I have gotten for under our Skype bounty. But have an introduction, don't be rude, don't be sassy, have a clear explanation of the vulnerability, and make sure to have a proof of concept. This is my favorite line, waiting eagerly for bounties. It's like the best quote I've gotten. All right, so the next, and this may also seem a little obvious, but the severity matters. If you have a low severity report versus a high severity report, they will give a higher payout on the higher severity. So things to consider, what user action is required? If there are 5 clicks required by a user, that will get a lower payout than a vulnerability with, say, 1 click required by the user. The number of versions impacted and the number of endpoints impacted also plays a huge role in this. All right, so what doesn't matter in your report? These are some of the most common vulnerabilities that we have gotten that, it's really great that you found it. We will definitely take note of it, but 9 times out of 10, I don't want to say all of the time, but 9 times out of 10, these will not meet the bar for security servicing. So the first, social engineering. If you can get someone to click on a link, if you can get someone to, fall for a phishing email, good for you. That's not a security vulnerability as far as bug bounty programs are concerned. The next, man-in-the-middle attacks and physical access. If you already have physical access to someone's device, again, that doesn't always prohibit you, but that is a huge knock against you having physical access to that device. All right, so I have 2 other questions for challenge coins here. Another big one that we get that isn't necessarily qualifying of bounty is self-cross-site scripting. Does anyone know what that is? Or why that might not count? Anyone? Yeah.
Because it only affects you as a user?
That is a great guess, but that's not the definition that I'm looking for here. Anyone? Okay, so a self-XSS basically means that you are requiring a user to attack themselves. So you're convincing a user to copy and paste malicious code into a text field or a text box. And this does not count because it is social engineering, essentially, getting a user to inflict this vulnerability on themselves. So the next thing that we don't count is email header spoofing. So this is essentially relatively easier to do. And the reason that this doesn't count is it is on the user to confirm the identity of the user or of the person sending them that email. So this is another common one that we get that is not eligible for bounty. So lastly, clickjacking. Does anyone know clickjacking? Yes.
So for this, it would be more or less to where you're more or less manning the middling by them trying to connect to a Microsoft service, but instead redirecting them to a page to where you created the site yourself, and you, in essence, all positive links go to a negative site.
Mm-hmm. Yeah, absolutely. That was a great explanation. So just in case anyone couldn't hear, it's basically getting someone to click on something and redirecting you to a different site than what they initially expected. So this will count if you are able to add a button or add some sort of trigger in the actual UI of the original website. What is not eligible is if you are able to insert an iframe into a website and then get a user to sign into Facebook or their bank account or something like that. So inserting an iframe is not considered an eligible clickjacking vulnerability. Are there any questions on that? Okay. All right, awesome. So the biggest piece of advice I give you if you are looking to participate in a bug bounty program is to go further. If you find a vulnerability in Apple software, you're going to be so excited. You're going to write your report. You're going to submit that immediately. Yay, get your big payout. My suggestion for you would be to wait a couple of days. Check for variants. See if you can go further with that vulnerability, both with breadth and with depth. So ask yourself, could this vulnerability affect other endpoints? Additionally, could you use this vulnerability to gain more access? Could you use this to go further? A lot of companies will not pay you if your vulnerability report makes them realize that there is a bigger security flaw in their system. They'll be like, great, thanks for submitting, this like little XSS vulnerability, we'll pay you for that. when in reality we realize that that same attack could be used for a much bigger problem. So where do you start? This is great, you know, oh yeah.
But just that go deeper, gain more access, isn't that where it starts to get into a gray legal area as to what you're legally allowed to access? Because you could be going to, like, let's just say office.com, but behind the scene there's access to some private internal backend with which, how does the legalities work out?
That's a really great question, and for most answers it really depends on which specific product you're looking at and whether that's online or on-premise. So one of my biggest suggestions on here is, you know, create your own test tenant and only work on looking at vulnerabilities within your own test tenant. It is likely that that may trigger something internally with Microsoft. It is possible for you to go ahead and, sorry, I know I'm not looking at Microsoft specifically, it's just what I'm most familiar with. So it is very likely that that could trigger something, but for the most part, if you're able to create your own test tenant and try to isolate that as much as possible, that would be my recommendation to not really step on any toes.
Even if it makes a callback to some centralized server?
It is a gray area. I think it depends so much on like exactly what you're doing, and if you're only trying to access your tenant's user information versus doing callbacks and trying to get server information from everyone. Those are two very different things. So saying, you know, I found this vulnerability that gets information from, you know, users within my test tenant, and it could be used, you know, to gain server access. You know, just making sure that you verbalize that it has broader business impact would be my best suggestion.
Okay.
Yeah, that was a great question, though. So that was actually a great lead into my best suggestion would be to creating a test tenant. Also, keep in mind the difference between a vulnerability and a bug. You know, you don't want to be looking at something that is technically by design or the way that the software was created. It's just not something that you agree with or you think that there could be security issues with. You want to find an actual vulnerability within that software. Do you have a question?
Yeah, what's a test tenant?
A test tenant, great. So say you are looking for vulnerabilities within AWS. Don't just start attacking their server, like create your own instance. You know, maybe create some users. I just think of SharePoint because that's what I work for most. Like create your own instance of SharePoint, create a whole bunch of test users, and then go ahead and try to see like, okay, if you're a user versus an admin versus a global admin, what can I click on? What can I do that gives me more information or more access than I'm supposed to have? This isn't necessarily going to give you like the biggest payout. These aren't the most severe vulnerabilities, but if you're looking for a place to start, I think this is a really great place to kind of get your foot in the door and start finding those like low-hanging fruit. Also, so I threw in here a couple of resources that I recommend. I know, you know, just coming to these clubs and doing CTFs and hackathons and things like that, you know, are going to give you a lot of knowledge about doing pen testing, about doing red teaming. So I'm sure you guys already have a whole list of resources on your own, but here's a couple more that I would definitely recommend. All right, so that's all I have for you guys. Do you have any questions for me? Probably asked them throughout, but yeah. All right, well, cool. Thank you very much. I'm just going to leave a hand.
In a week today.
Reddit's down.
That was cool. Oh. Yeah, thank you so much. Is this yours? No, it's not. All right, I have one back. Yeah. Wow. You think you could just come up here and present?
I think I could just wow.
Old move.
Look at that beautiful sponsor on the bottom. It's getting me all hot.
Wow, look at
Why is it like the lower tier sponsors have bigger pictures on the next slide?
All right, hey guys. So I'm going to take a moment before we get started with our education presentation today. I just want to thank the sponsors. I want to thank Eden, Ingressive, Palo Alto, Facebook, all these people up here, right? Thank you so much for all that you guys do. Honestly, we couldn't do it without these guys, so we really appreciate the support and the love they give our club. So, and then gold, silver, and bronze as well. Thank you so much. Yeah, round of applause for our sponsors. Let's go. Woo, yeah. All right. Cool. So without further ado, we brought in a special guest, actually a young gun of the security world, Stuart, presenting on binary exploitation. So everyone give a warm welcome to Stuart.
Where do you clip this in?
You're just gonna clip it on, and then you can like put this in your pocket.
Okay.
Yeah, see that can before you do somewhere? I'm gonna swap your batteries out real quick.
Okay.
Good to go?
Awesome. Okay. Hey, everybody. I'm Stuart. We're going to be talking about binary exploitation this week. So apparently the slides are uploaded at this link, week7slides.ritsec.club. So first, a little bit about me. I'm Stuart Nevins-Locke, for those of you who don't know me. I'm really into most low-level things, especially binary exploitation, but I also enjoy reversing and other such things. I'm also the leader of reverse engineering interest group. If anyone's interested in this sort of content, I totally recommend going to that to learn more of this. And one other thing, I just really like chess. So yeah. So to start off this presentation, I just kind of want to say like what binary exploitation is, because a lot of people might have heard about it, but not really know like actually much about it. So the basic overview is that binary exploitation is pretty much just abusing some flaw in software to make it do something that it was not intended to do. So one of the recent definitions that has become really popular is looking at like software as a state machine. For those of you who know what like DFAs are, you can basically just think of software as something that has various different states, and finding like a vulnerability would be making it go to some state that the programmer did not intend. So in binary exploitation, we're pretty much just trying to take some program, some piece of software, and make it go to some state that the programmer didn't want, pretty much some state that we choose. So how do we actually find those? Typically, you want to look at things the programmer didn't think about. So for the next slide, I actually want to talk about how we would go about finding those. So to start, when like finding a vulnerability is the first thing you need to do in terms of making an exploit. First, you need your vulnerability, then you can write an exploit. And this is generally like the most time-intensive part of the binary exploitation process, because finding vulnerabilities is often really hard. So there are three main steps that I kind of break it down into. Step number one would be finding some piece of code to analyze, like some piece of code to attack. There are various like heuristics you can use to decide what piece of code to attack. I'll go a little bit more into this later, I think. But to start, some things you could do is just look for code that has like messy logic, or that has had a lot of bugs in it before, or is just like really important to the security of some software. And after you've decided on what you want to attack, you have to actually analyze what you want to attack and fully like understand it. Basically reverse engineer the piece of code you're looking at. And then finally, the third step in this would actually be like discovering your vulnerability. And there are various like known vulnerability classes. I'll go into this more later also, but just brief overview, you have some stuff like integer overflows, array out of bounds accesses, and buffer overflows, and really a ton more. But yeah. So more for step one on how we'd actually find some piece of code that we want to attack. Because if you just randomly say, oh, I want to attack this piece of code, it's really not all that likely that that's like the most efficient route to finding some vulnerability. And we don't really want to waste time. We'd ideally just find a vulnerability as quickly as possible so we can get on to exploitation, which most people think is a lot more interesting and fun. But anyways, so one of the main, I'd say most common techniques for deciding like what code you want to look at is looking to see where vulnerabilities have been found in the past. So like the CVE list is a great way of doing this. You look and say, OK, VirtualBox had some vulnerability in this function. And you go and look maybe more at that function or more look more at functions in that same file, or just functions related to the function that had a vulnerability. So basically, just if some piece of code has vulnerabilities, it's probably going to have more. This is actually sometimes true because you just have one programmer who doesn't code in a very secure manner, and you can just kind of continue finding vulnerabilities in their code until eventually they're all fixed. But that's not like the only way you can decide on what to attack. Another thing you might want to do is find some like important code to security. So for example, if you take like user space in kernel space, obviously finding like a ring 0 exploit in kernel space is a lot more interesting than finding something in user space, because you'll get a lot higher privileges if you can exploit something running in the kernel rather than in user space. And another example of this is like browsers, for example, run a lot of things in sandboxes. So ideally, you'd be able to attack the parts that don't run in sandboxes. That might be harder, but it's much better like results if you can find a vulnerability in something that isn't sandboxed. And then finally, a third heuristic you can kind of use is just look for places where the logic of the programmer seems like messy or warped or whatever. Like for example, if they have a bunch of redundant checks, it's probably true that they don't really understand the code that well and are kind of just not wanting to break anything. So you might be able to kind of take advantage of that. Also, like, yeah, if there are just a ton of preconditions or no preconditions to functions, sometimes that can also be something you notice. So the next step that I mentioned before was step 2 in this finding a vulnerability process, was to actually analyze like the code. So once you've actually like said, OK, I want to attack this file or this piece of code, this folder, whatever, you actually have to do a ton of work from there, just understanding what that code is doing. Unless you happen to be an expert in that area beforehand, which is really unlikely, this is probably going to be the step that takes the most time. It just requires a lot of reverse engineering, especially if you're actually just like targeting a binary, a closed source binary. Then you have to do a ton of reverse engineering, looking at assembly and everything. That's a lot of work. So typically, it's easier to just attack open source code or just like hope your code has some open source version. Reading C code or whatever code you want to read is just a lot easier and more fun than reading assembly. It's kind of just true. So once you kind of get some higher level understanding of the code, you want to go and figure out exactly what you control in the code. Like maybe you control some inputs to a function, and you need to figure out exactly what inputs. And you also want to figure out exactly what changes based on the inputs. Like for example, maybe if you give some various inputs, it'll actually return a value that it shouldn't or something like that. So you want to try to figure out exactly what you can control and what you can do with what you can control, looking at like side effects and such things. And one thing is a lot of people kind of overlook this step because it's definitely not glamorous. It's by far like the most boring, I'd say, part of it. But it's also incredibly important because if you don't really understand the code, it's going to be very hard to first find a vulnerability in it, and second, actually like, exploit that vulnerability. So finally, to the third step in this process is actually like you understand your code fully now, and you want to find your vulnerability. There are two major kind of approaches to this. One is just automatic review, which is not something I'm really going to talk about a lot. That's just there are two common ways to do this. One, you have static analysis, which is just like run some program on the code that analyzes it for you and hope it produces some interesting results. You don't actually necessarily have to have some great static analysis tool. Sometimes if you just compile software with like warnings enabled, you'll actually just find things that could turn into vulnerabilities because not everybody compiles with warnings enabled, or sometimes they just ignore the warnings. So that's actually one way you can sometimes find vulnerabilities. And then the second one is fuzzing. Again, I'm not going to really talk about this past this, but fuzzing is basically some program just tries to find bugs for you. You just tell the fuzzer, hey, attack this, and it just spams a ton of input and hopefully finds a crash. Then the other approach to actually finding vulnerabilities would be manual review. This can get you a lot like more kind of in-depth issues that are often like harder to find and wouldn't be discovered by automatic analysis. It requires a lot of time. It requires you to read a lot of code and to understand common vulnerabilities. But when you're doing this manual review, you typically want to look for common issues, which I'll talk about a little bit more. And this is also another really time-consuming step. Just finding vulnerabilities can often take forever, even after you've understood the code fully. Because also sometimes there just aren't any vulnerabilities in the code you're looking at. And there's no way to actually know if there are going to be any. So sometimes it can be really frustrating because you can just think there might you might be missing something when in reality you're not, and it could just be secure code. There's no way to know. So that can be annoying sometimes. So here's some common known vulnerabilities that you should keep in mind when you're doing this sort of vulnerability discovery. So first, we often group single vulnerabilities into these things called vulnerability classes, which are basically just groups of vulnerabilities. So for example, buffer overflows. I'm definitely going to talk more about this later. But a single buffer overflow vulnerability would be within the vulnerability class of buffer overflows in general. And those are basically just reading too much data into something. You also have integer overflow. That's another very, very common one. And that's not a vulnerability in itself, but it is often leads to vulnerabilities. Then another one is uninitialized memory disclosure. The way I kind of describe this is just you never give some variable a value, and somehow it's used. This is often done for optimization purposes, like giving it a value. Initializing all your variables has some overhead, so sometimes programmers think, okay, whatever, I won't initialize this variable because it shouldn't be used in whatever path. But sometimes it can turn out that they're just wrong, and you're able to use some memory that hasn't actually been given a value. That's one of the more interesting ones, in my opinion, just because it's not seen a ton, but it still is out there. That's also a great one for compiler warnings, because compilers typically will warn you about this. Though people often, as I said before, just ignore compiler warnings because they don't care enough, or they don't think it can be an issue. And then the final one I'll talk about now is just printf. Many of you might or might not know this, but if you use printf incorrectly, it's actually very easy to turn into a vulnerability. If you just printf some user input, they can give these things called format specifiers. So if the user inputs say %i, and you do printf of whatever their string is, which in this case would be %i, what printf will actually do is it's just going to look at whatever's on the stack, and it's just going to print out whatever's on the stack as an integer. So if you just put 500 %i's in a row, it would just dump a large portion of the stack. So there are actually some interesting ways that printf can be exploited. For example, there's a %n format specifier, which seems to have been added just for the purpose of allowing these printf vulnerabilities to actually be totally exploitable. It's really strange. Yeah, it's great. It's the only format specifier that actually writes a value to memory. So yeah, for seemingly no reason, it just takes a pointer and it'll write some value to that you can control. So typically, they're actually exploitable, and these are a great way to exploit things. And not a ton of people know about it, but it can be very frustrating to exploit. I'll say that. I hate exploiting print format vulnerabilities. Very time-consuming and just annoying. Anyways, there are a ton more of these vulnerability classes. If anyone's interested, I'm happy to talk about other ones. Some things include race conditions, use after freeze. But anyways. So now I'm actually going to talk about what I consider the interesting part, exploitation. So this is where you actually get to feel like a real hacker. So to start, let's talk about buffer overflows. I'm going to focus on stack overflows because those are a lot simpler in terms of actually exploiting than heap overflows or other overflows in general. So the root cause of buffer overflows is if you just read too much data into something that doesn't have enough storage space. So for example, if I have some array of size 50 bytes, and I store 100 bytes worth of data into that 50-byte array, that's going to cause a buffer overflow. Because what it's going to do is it's just going to save the first 50 bytes of your input into the first 50 bytes of the array, and then just save the next 50 bytes to whatever's in memory after the array. And that's very, very dangerous. So there's some really famous functions for doing this, such as stir copy and gets. Gets has actually been removed in the latest C, I think, C14 it was removed in. Because if you call gets, it's basically guaranteed that you have a vulnerability in your program. That function kind of is inherently vulnerable. And it actually kind of surprises me that it took them 14 years or however long to remove it. But another one famous for this is stir copy. Stir copy copies a string to another string, but it doesn't do any bounds checking. So if you provide it a really long string to copy, it'll just keep copying past the bounds of the first string. And then there are some functions that aren't commonly known to do this, like fgets and stir ncopy and memcopy. But these all take a length parameter, how much they should read and how much they should copy. But it's often common that you can, or not often common, but sometimes you can trick them into copying the wrong amount. For example, if the length is just some user input, if you have a buffer of size 50 and then they say how much do you want to copy, you could just say, oh, copy 70 bytes, and it would copy 70 bytes. So those fgets, stir ncopy, and memcopy can all be vulnerable too. you don't necessarily need gets or strcpy to actually have a buffer overflow. So now to actually like understand how you'd go about exploiting this, I'm going to go a little bit more in depth about how memory actually looks and how we'd actually do things, and in what we can overwrite when we write 100 bytes rather than just 50. So to start, I want to talk about stack frames. And every function in C has its own stack frame. Here's a little visualization. We have some function that has a buffer of size 16. That's 16 characters, and in this most versions of C, a character is going to be exactly 1 byte. So that's going to be 16 bytes of local variables in the func thing, the func function. And then it calls the gets function, which I've already said just reads however much input you give. So that's easily going to be a buffer overflow. If you just give it 32 bytes, it's going to read 32 bytes and save that. So now to where it'll actually save those 32 bytes, if you look all the way to the right, those three things make up the stack frame. So every function has a stack frame, as I said, and each function's stack frame is made up of local variables, the previous base pointer, which we won't be talking about at all. Don't worry about what that is. And then the really important thing here is the return address. Just a note, sometimes you'll have like parameters to the function in the stack frame, depending on your architecture and the number of parameters. I'm just going to ignore those to make it simpler. So in this example, we just have one local variable buffer, which is 16 bytes. So at the bottom, you'd have 16 bytes of local variables. Then you'd have the previous base pointer, which I said we don't care about. And then you have the return address. And this is the really important part. In the case of the stack frame of func, the return address would be pointing to main. Because at the end of the func function, it would return, and it would, the assembly code has a ret instruction. And the ret instruction will just go to wherever the return address says to go. So in this case, the return address would say to go after the func call in main. So the return address would be pointing to the return 1 in code, basically. But we have this gets, so we can actually overwrite the return address to whatever we want to. So in terms of actually exploiting them, we know we can now overwrite local variables, the base pointer, which we don't care about, and the return address, which is, again, super important. So what if we actually like overwrite our return address to some function that happens to give us a shell? Like say you just had some function that's like give me a shell. If you just made the return address point to that function, it would do exactly that. You just get a shell. So it really works amazing if you just happen to have some function in your code that just gives you a shell. But obviously, most code won't just have some function that's called give me a shell and gives you a shell. So this would work great, like it would really work great if we could get around that. So 15 years ago, what people would do is they'd do this thing called shell code. They'd write their own, basically, assembly code. They'd compile it to machine code. And then they'd send their machine code. They'd overwrite in like the local variables with their machine code. And they'd say return. They'd put their return address to where their shell code lives. So they'd basically just put in some code, and then they'd return to the code they inserted. And this was called shell code. But sadly, this worked like 15 years ago, and this does not work anymore. I think this was introduced in like Windows Vista, like DEP, which I'll talk about more later. But basically, this doesn't work anymore. This is good to know about, but yeah. So just a little visualization of what we're actually able to control when you do a buffer overflow, stack buffer overflow attack. You have those same three things, the local variables, the base pointer, and the return address. And when we have this buffer overflow, we can control all of those things. So yeah. Now to talk more about the problem of like, what if we don't have some function that just does call me? And because we're in 2019, there's no shell code possible. If we were in 2004, that would probably be doable, but sadly no. So there's this thing called ROP, which stands for Return-Oriented Programming. And basically the goal of this is to get around those protections that I talked about before that prevent you from inserting shell code. So if you think back to our method of exporting these buffer overflows, we overwrite the local variables, we overwrite the base pointer, and we overwrite the return address. And we're overwriting exactly one stack frame. But who says we're limited to overwrite one stack frame? We can overwrite as much data as we want to. So if you think about it, we could actually just overwrite those previous stack frames too. And all those previous stack frames have return addresses that we could overwrite. So that's basically the concept behind ROP. It's a little bit more complicated in actually doing it. But the basic concept is you'd think main has a stack frame, and main stack frame is going to have local variables, base pointer, and the return address. So you just overwrite the return address in main stack frame too. So then you can return to multiple pieces in the code. And if you return to enough of these small, they're called gadgets, ROP gadgets. If you basically overwrite enough return addresses to point to each of these small ROP gadgets, you eventually have a ROP chain. And in many programs, these ROP chains can actually be totally Turing complete. They can do whatever you want them to. There are various really nice programs for finding ROP gadget, like one titled ROP gadget. And they just print out ROP gadgets that you can set your return addresses to, and they'll do various useful things. One thing to note is ROP gadgets are all often very short. Typically, they're 1 or 2 instructions long. So you might have to have a large ROP chain of 20 return addresses to do anything really important, because you can only generally execute 1 or 2 instructions at a time for every return address you do. And generally, you're going to want to do more than just 1 or 2 instructions in total. So you might have to have 20 of these ROP gadgets chained together to make a fully functioning ROP chain. So that's basically the idea behind ROP. So now I'm going to talk a tiny bit about the actual mitigations and why, for example, shellcode doesn't work and what those annoying security people are doing to prevent us from actually just making this really easy. So the first mitigation, and I'd say probably the most famous, is ASLR. That stands for Address Space Layout Randomization. You sometimes will hear people call it ASLR. The basic idea is it randomizes offsets of sections in memory. So there are various sections in memory. You have your stack, you have your heap. You're going to have the program code in there somewhere. You're going to have a bunch of libraries. And it doesn't actually randomize where things are relative. Each section is a start address, basically. So what ASLR does is it doesn't actually randomize where things are relative to the start address of the section. It just randomizes the start address of the section. So for example, if your stack started at address 700, and there was something interesting in there, 16 bytes from the base of the stack, if you ran it again, the stack might start at address 900, but the interesting thing would still be 16 bytes off. So the key thing here is that offsets are all actually the same in ASLR. ASLR only applies to sections in general. And one thing is sometimes ASLR will actually apply to the program itself. This is, I think, different on Linux and Windows. I think it has a larger overhead to actually do on Linux. It takes a full register. It's actually a different thing called PIE that will apply to the program on Linux, position independent execution. But basically, ASLR by itself just randomizes the stack and heap and other sections like that. And the reason why people first thought to do this is basically you can't return to something if you don't know where it is. So if you think back to us overwriting the return addresses, we'd have a return address point to some useful place. But if we don't know where anything is, it's really hard to point to some useful place. And it's actually really annoying. So often exploits will require 2 pieces, one to bypass ASLR and another to actually take control of the program. Though again, this is very dependent on how you're exploiting it. So the next mitigation is DEP. It's data execution prevention. You also often hear of it referred to as NX, which stands for non-executable, or W XOR X, which is writable XOR executable. Basically, it's saying that you never want to have a section of memory that's both writable and executable, because you never want to be able to write something in it and then just run that immediately after. Generally, this is true for most programs. Most programs aren't doing compilation, just-in-time compilation, so they don't really care about actually writing to and executing memory. Some do, but that's pretty uncommon. Stuff like browsers do. So yeah, the idea is that it just makes it impossible to execute certain areas of memory. And this totally breaks shellcode. This was the first way to break shellcode, I think, because you can't just write some shellcode to some area and then execute it, because you'll never have an area that's both writable and executable. Though actually, yeah, as I said, that's changing a little bit with browsers, which have just-in-time JavaScript compilation, because those need to both write code and execute it. So things are different in that area, but most things this is true. And then the final mitigation I want to talk about, and probably the simplest, is stack canaries. So stack canary, the idea behind this is you basically put some random value on the stack at the start of the function, and then you check that that value hasn't changed at the end of the function. And you put that before the return address, basically. So if you look in this picture, this would be the same stack frame of some thing. You have the local variables, and then after the local variables, you have your stack canary. And then above the stack canary, you have the return address. So the idea is if you overwrote the local variables in stack canary and base pointer and return address, you'd have a changed stack canary. So the function wouldn't just return, it would like abort. You can't actually, with a basic overflow, change the value of the return address without changing the value of the stack canary. Though some, especially older ones, weren't necessarily random, and there have been various attacks on stack canaries. Now they're pretty solid and well implemented. But if you'll notice, the last two mitigations didn't explicitly target stack buffer overflows. They were kind of just general things that prevent you from doing things you shouldn't be able to, basically, run memory that shouldn't be run, and just randomizing stuff. This explicitly targets stack overflows and totally breaks them. In most cases, I'd say stack canaries were pretty much when stack-based buffer overflows stopped being super common and exploitable, because you really can't get around it without some other vulnerability in there. There's still sometimes you see them, especially if people just happen to compile their code without stack canaries, which shockingly happens. There's a very small performance overhead, but apparently some people actually care about the performance overhead. It's really completely negligible, but some people just compile it without stack canaries, and then you can still do this. So that's nice. So that's everything I'm talking about for today. Does anyone have any questions? Yeah.
What resources would you recommend, like books or websites or anything, to get more information?
Books or websites. I don't necessarily have any books in mind. I know pwnable.kr was mentioned before. That's a good one. I'd say, honestly, if you're interested, I would recommend coming to reversing. I last semester talked a lot about these in further depth. I'm probably going to do more of that this semester also. There are also some other cool websites like pwnable.tw. Also, generally, I'd recommend doing CTFs and the pwnables in those. Some of those are pretty easy. Some aren't, but those are a great learning experience. I've actually never really done any of those war games like pwnable.kr or pwnable.tw. Really, all of my experience is just from doing CTFs, and then some real world, like looking at programs and doing that. But yeah, good question. Yeah.
Just so everyone else in the room, everyone else in the room knows, what time does reversing group meet?
Good question. Yeah. Reversing group meets, I guess, Sundays 12 to 2 in Sec Lab. We're actually going to be talking about Chrome exploitation this week. So if anybody's interested in that, definitely come. But yeah. Cool. So yeah.
Sorry for the little boinging.
I did.
I was being bombarded. I tried to mitigate, but...
There's this one chat that kept doing @Nick O'Brien. Hello? Hey guys, the demo information is posted in Demo Help.
There we go.
And we have a scoreboard. It's back to using the Excel sheet or the Google Sheets thing. Yeah, a scoreboard. If there